Alright, welcome to another AQA AS chemistry video. Today's going to be a video on production of alcohols. And first I'm going to go straight into the types of alcohols. So types of alcohols are, alcohols can either be primary, secondary or tertiary. So a primary alcohol is one which has one carbon constituent bonded to the carbon which is bonded to the functional group. For example, ethanol. So you're talking about when you're talking about whether it's primary, secondary, or tertiary, you're talking about the carbon that's bonded to the hydroxyl group and whether or not that is bonded to another carbon group. Or not to no carbon group. So for example, if you're talking about ethanol, it's only bonded to one other carbon, and not two other carbons, and in itself, it's also the carbon that's bonded to the hydroxyl group. So this would just be a primary alcohol. Secondary alcohol is one which has two carbon atoms bonded to the carbon which is bonded to the functional group. For example, propantuol. So if I was doing propantuol, the carbon that's bonded to the hydroxyl group is also bonded to two other carbons, and that's what makes it a secondary alcohol. And then obviously tertiary alcohol is when it has three carbon atoms which are bonded to the carbon atom which is bonded to the functional group. For example, 2-methyl propantuol, and as hopefully you can see, it's literally the same principle, but now just three carbon atoms bonded to it. So OH and a methyl group here. Three carbon atoms bonded to the carbon which is bonded to the hydroxyl group, a tertiary alcohol. And then there's alcohol. So now we're going to go to actually how alcohols are produced, so alcohol production. And there's a variety of methods for synthesizing alcohols. Different methods are used for industrial purposes. So let's go for one mechanism, which is a hydration reaction. There's two mechanisms. There's fermentation and then there's hydration. The differences between ethanol production in fermentation and in hydration is that fermentation is cheaper, but the distillation can have extra costs. So I'll go through the hydration method first. The hydration is you have an alcohol, and it's usually production of ethanol, but it can work with alcohol with forming other alcohols as well. But let's go through forming ethanol. So fermentation of, so if we'll go with ethene. So for forming ethanol from ethene, so the alkene will be ethene that you're starting off with. And you'll use an acid catalyst, so be an acid catalyst. So it's going to be this hydration reaction is a type of electrophilic addition reaction. It's an electrophile being added. So come back here. It doesn't matter, it's a symmetrical molecule, so we can form a carbocation on either side, really. Hydration meaning you're using water. So before we had the dehydration reaction, and now that's when you're forming alkenes. That's what I told you guys to remember, it's a reversible reaction. You can form alkenes or you can form alcohols. So this method is the backwards reaction from before. It'll be forming an alcohol using water. So this is a hydration reaction. Oh, actually, carbocation here, and it'll be water that's acting as a nucleophile. So now you're forming this kind of structure here, but obviously oxygen only has 2 bonds, so it's going to, it's a positive there. It needs to gain an electron there. This hydrogen is lost as a H plus, and therefore you form your ethanol, and then you regain your H plus. So industrial alcohol reduction. So alcohols are produced by hydration reactions, which is adding water of alkenes in the presence of an acid catalyst. Is usually a strong acid catalyst which is needed, and the most common catalyst is used, which is phosphoric 5 acid, or H3PO4, and it's done at 300 degrees Celsius, 500, which is also 573 Kelvin. You can use either, and 60 atmospheres of pressure. Now, these usually tell you that, you know, from my experience, that you should remember at least some of these things, but you know, for most parts of the exam, I'd recommend remembering these, but from my experience, they just want you, they're usually okay with you saying high temperature and a high pressure, but I'd advise remembering. Sometimes specifics do matter. Like, there are examples where they want you to remember the temperatures and the pressure, but I'd still, you know, you can, there are instances where they just say high pressure and high temperature. And as I said before, this reaction is an electrophilic addition reaction. So hydration of ethene, the mechanism, you know, shown above. So the acid catalyst acts first, and is attacked by the alkene, and the lone pair of oxygen, the lone pair on the oxygen of the polar water molecule. So this polar water molecule here, this has the lone, so the lone pair is on the oxygen of this polar water molecule, and that's what's attacking the carbocation on this carbon atom here. It attacks the carbocation on this intermediate here. And then finally, when that happens, a proton is lost to form the alcohol and reform the acid catalyst. So that's how, obviously, this is from the phosphoric acid, and it's obviously acting as a catalyst because it's not being used up in the reaction. It can be used, but not fully used up. It will return back. So you have now a H plus here, because it's broken off here, and that would be used to reform your acid catalyst. Therefore, it's not, you know, it's not being used up, which is the characters of a catalyst. There's also fermentation. So for some purposes, ethanol is produced by fermentation, which makes drinkable alcohol. But it can also be used for making biofuels. So fermentation uses yeast to turn glucose into ethanol. And the reaction for it is, as you remember in GCSE or for A-level biology, which is the anaerobic respiration of plant cells or yeast. So it's here with C6H12O6, and then that gets, when that reacts to form 2 molecules of ethanol, C2H5OH plus 2 CO2. And obviously this is at 40 degrees Celsius with yeast, in yeast cells. So ethanol is produced, so ethanol is separated by simple distillation, and this process is cheap, but distillation can add extra cost, you know, making it refined. So it's kind of variable to say it's a very high cost. It could be very high, it could be very low, but this is dependent on the molecules that you have and the equipment that you have can cause extra costs. So biofuels, what are biofuels? Biofuels are fuels composed of grown organic matter. So the biofuels that you need to know for your A-level chemistry exams are, which are ethanol, which is produced by fermentation and then separated by fractional distillation, and this can be used as biofuels. But biofuels are more eco-friendly than petrol because they're renewable. They're renewable because they infinitely grow, and they're more sustainable. they're carbon neutral, kind of, because the CO2 that they release when they burn is also absorbed when plant cells undergo photosynthesis, and they absorb this CO2 for development. So that's why it's carbon neutral to that extent, because they cancel each other out. There are some problems though, because switching to biofuels, it can be problematic, because car engines aren't really built to run on ethanol, and the land that's growing biofuels isn't producing food. Did I say are? Should be aren't. You know what? Here we go. All right. So car engines aren't built to run on ethanol, and land that's producing biofuels isn't producing food, and that can lead to food shortages. There's also the fact of, as I said before, let's go down into carbon neutrality. And earlier I said that biofuels are kind of carbon neutral, and yes, the CO2s that they release are absorbed when they grow, for when the plant cells use them, absorb CO2 for photosynthesis. But it's not the complete story. You still need, because you need to put this down. Because you need fossil fuels to make crop fertilizer, to harvest the crops, and to transport the biofuel. And transporting it, you have these massive lorries transporting it, and they use carbon. They use fossil fuels as well, which release lots of CO2. So all these processes they use fossil fuels. So from harvesting the crops, growing, using, producing fertilizers to make fertilizers, to harvest the crops, transportation, they all use fossil fuels. So it's not entirely, all these processes make CO2, so it can't be, that's why I say it's not completely carbon neutral. So when we talk about carbon dioxide, it can be given off. The whole point of these biofuels is meant to be making it more sustainable. So you have to wonder. You probably might get a 6 marker in an exam, which may ask you to evaluate. And it's usually you get one of these examples. I think it was an example 2 years ago. I'm not entirely certain what the exact question was, but it was comparing biofuels and their use. So you will get a 6 mark question in the exam, where they might ask you to compare biofuels to normal fossil fuels, advantages, disadvantages, and it's all about CO2 emission mostly, as well as how efficient it is. So if we're talking about CO2, it can be what's given off and then what is absorbed when we're talking about biofuels. Absorb CO2 when plants are grown, so biofuels absorb CO2 when grown. They give off, and they obviously CO2 is given off when biofuels are burnt. And extra processes during biofuel production and preparation. And that can be split onto transporting, as I said before. So these extra processes during biofuel production and preparation are coming from transportation, or from making fertilizers needed to grow crops. And that's it. Hopefully this video helped. That's it.